This is transforming the square root function. The square root function can be denoted by y is equal to square root of x. And a way that we can visualize this is by plotting points from a data table. So here we have x of 0, 1, 4, 9, and 16. And since we find the square root of that, we would get y is equal to 0, 1, 2, 3, and 4. And if we were to graph that on a graph, we would get this. So with transformations, we can shift this function to the left or to the right. So first off, we can shift it to the right by doing y is equal to square root of x minus 2. And although it says x minus 2, the reason that the function shifts 2 units to the right is because given that y is equal to 0, we would need x to be equal to 2 in order for the entire right side to equal to 0. And in this bottom graph, given that y is equal to 0, x would also have to be negative 2 in order for y to equal to 0. We can also shift the function upwards and downwards. So given y is equal to square root of x, if we did plus 1 on the outside of the radical, it would shift the entire function up 1 unit. And this is different from before, where we put the addition and subtraction inside the radical. Therefore, the function moves up and down because let's just say that x is equal to 0, then the square root of that would be 0. And if we were to add 1 on the outside, then that would make y equal to 1. And the same thing goes for subtracting 1. Now we can also flip the function to the left here by adding a negative sign inside the radical. And this is because if we want y to be defined, x cannot equal any value greater than 0. Because if x is greater than 0, then a negative inside a radical, then we would be dealing with imaginary numbers, which we don't want. So then x would have to equal to any value less than or equal to 0. So this is why the function is turning towards the left. And if we were to put the negative sign outside of the radical, the function would flip downwards because for any value that we get of square root of x, we'd multiply that by negative 1. So given that x is 1, then y would equal to negative square root of 1. So then that would be negative 1. And so the function would be flipped downwards. In our first example, we have to graph y is equal to negative square root of x plus 3 minus 1. So we can break this down into many smaller steps. And the first step we can do is by graphing y is equal to square root of x. And we go from there. Next, we would include the plus 3 inside the radical. And as we know from before, this shifts the function 3 units to the left. And then by adding a subtract 1 on the outside, this would shift the graph 1 unit down. So this is the graph from the last slide. And then the final step would be to add the negative sign on the outside of the radical, in which we get the graph we want for y is equal to negative square root x plus 3 minus 1. For our second example, write the function based on the graph. So we are given this graph, and we know that on the original graph of y is equal to square root of x, its starting point lies at the origin, which is 0, 0. And here we can see that the starting point of this function is at the coordinate of 2, 1, so that we know that the function was shifted 2 units to the right and 1 unit up. And from that, we can write this function y is equal to square root of x minus 2 plus 1.